An introduction to exponential functions, exponential decay. What is an exponential function? Let's review. What is an exponential function? A function is a relationship between two variables. The input variable, the information going in, and the output variable, the results coming out. The function is written as f at x is equal to 2x. We read this, as I just did, as f of x equals 2 to the exponent x. This is called function notation. The function name is f at x. The input variable is x. What happens to the variable we represent by the right side 2 to the exponent x. The two categories, exponential growth and exponential decay. Now we're going to take a closer look at exponential decay. Here is an example. Uranium is commonly used as fuel for nuclear reactors. Uranium comes in a variety of forms, or we call them isotopes, some of which occur naturally and some of which are produced through a process called nuclear fission. One isotope, called uranium-239, has a half-life of about 2 years. This means that after 2 years, half the amount of U-239 has decayed or changed into a new substance. Now, in this example, the base value will represent decay. Here is an example. Suppose you have 1,000 milligrams in a sample of U-239. How can you model the amount remaining over time? Let's start by looking at how to solve this using a table of values. We set this up so that the first column, X, is the time in years, Y is the number of half-life periods, and one half-life period is 2 years, and after the half-life year, 2 years, the amount of U-239 remaining. So, the initial value we are told is 1,000. So, time in year 0, no half-lives have occurred, so we have 1,000, our initial amount. Now, after 2 years, we've had one half-life occur, so our value has gone from 1,000 to half that amount, 500. So the amount remaining would be 500. Now, year 4, another half-life period has occurred. We've gone from 500 to half that amount, 250. Year 6, 3 half-lives. We're now down to 125. Year 8, 4 half-lives. We're down to 62.6. What equation could we use to represent this function? We know the initial amount is 1,000. We know it's a decay question, half-life, so the base is 1/2. Since we know how much was left after 8 years, let's verify this amount by setting the time to 8. And of course, the period is the length of one half-life, which is 2. The final amount is how much of the sample will be left after 8 years. Putting this into an equation, we will get the final amount, the initial amount, the base, the time, and the period, just like we had with exponential growth. So substituting into the equation, we know that the amount final is what we're trying to find, so we'll leave it as a variable. The initial amount is 1,000. The base, half-life, 1/2. To the exponent time, 8, divided by 2, the period. And if we were to calculate this, we would get the final amount of 62.5. If we compare this answer to the answer we found using the table of values, we can verify that our equation and our table of values, since they are the same, we are correct. Now, here's another example. When U-239 decays, it forms a different material called plutonium-239. This highly toxic waste material has a much longer half-life of 24 years. Determine approximately how long it would take for a 50 milligram sample of Pu-239 to decay to 10% of its original amount. How to do this? Step 1, list the data that is given in the question. The final amount, 10% of the original, so 10% of 50 is 5. The initial amount we just said, but let's refresh, 50 milligrams. The half-life base, 1/2. The period is 24 years. We're trying to find time. So time is our unknown value in this question. Substituting these values into the equation, amount final is equal to amount initial, base to the exponent time divided by period. We will see that 5 is equal to 50 to the base 1/2 to the exponent x divided by 24. Now we want to solve for x in the equation. Do we know how to do this? Well, we could take 5 divided by 50 and we would get 0.1 is equal to 0.5. I put 1/2 so we're working in decimals, to the exponent x divided by 24. And now we need to solve for x. Now you could guesstimate this, trying numbers in your calculator, or we could use a new technique called logarithms. Logarithms is a form of the inverse to the exponential function. This will be covered in grade 12. Grade 11, you just are introduced to it to help you solve this type of question. How does it work? You are going to take the log of each side. To do that, you write log 0.1 equals log 0.5 to the exponent x divided by 24. Now, apply the power law of logs. That will give us log of 0.1 is equal to x divided by 24. The power law simply says you can rewrite the expression with the exponent in front of the log. So we'll have log 0.1 equals x divided by 24 times the log of 0.5. From there, we can take log 0.1 divided by log 0.5, and that's equal to x divided by 24. To do this step, we're just using your laws of how to move values from left side to right side. If we want to go from the right to the left, we have to divide both sides, of course, by the same value. When you're changing equations around, it is critical to note you may not change the value of the equation. If you do that, you've changed the whole thing. It's not a good thing when you're mathematical modeling. On your calculator, take the log of 0.1, divide by the log of 0.5. This is going to equal x divided by 24. So 3.32193 is equal to x divided by 24. And now your next step, cross multiply. X is equal to 24 times 3.32193, which gives us 79.726. So what does that tell us? It tells us that the number of years required for U-239 to decay to 10% of its original value, it would take 79.7 years. Coming soon, the next video, Laws of Logarithms.